right, let's write our first proof. So this is an algebraic proof. We're just given a simple algebraic equation, and basically what we're going to do is we're going to solve this equation by breaking it up into simple steps and writing down our reasons for each step. Step 1 in a proof is always your given. So this is exactly what was given to us. This is our very starting point, and our reasoning is it was given to us. You will always write down your given as your very first step. And then you're going to start to use your given to help you flow through the proof to complete each step. Now what we do is we look at step 1 to determine what happened from step 1 to step 2. It looks like what happened was I subtracted 3x from both sides of this equation to arrive at step number 2. And so what I did was I used the subtraction property of equality, or I'm just going to write subtraction property, to get from step 1 to step 2. Now from step 2 to step 3, what looks like happened was I added 18 to both sides. And so since I'm adding the same number to both sides to get to step 3, that's the addition property. Number 3, it looks like I divided by 5 on both sides to get to step 4. That was the division property of equality. And now we're not done, because we want to prove that x equals 6, and we proved that 6 equals x. So what we're going to do is we're going to flip-flop the x and the 6 and mirror it. And remember, the mirror property is the symmetric property. And that's our first proof. We did it. Now I may move a little fast for your writing skills, so make sure that after I'm done with the whole proof, you can pause the video and you can write down the steps. All right, number 2, same thing. This is a 3-step proof. We start with our given, so that's exactly what we're starting with. And then what happened from step 1 to step 2, it looks like I subtracted 5 from both sides to get to step 2, and that is just the subtraction property. And then lastly, from step 2 to step 3, it looks like I divided by 3 on both sides to get k is equal to 4. So that was the division property. And that is it. Now let's write our own one. Sometimes you'll see a 2-column proof in table format. Sometimes you'll just see it like this, where it's like more of a loose table. You need to draw it yourself, so I need everybody to draw a horizontal and vertical line and then write statements on the left, reasons on the right. If you need time to pause the video to do that, please do. Let's get started. So our first step always in our proof is what's given to us. So I'm going to write down what's given. Then what happened, or what I'm going to do to get from step 1 to step 2, is I'm going to start to solve this equation by adding 5 to both sides. You don't need to write the add 5. You can just write the next step, which is negative 6a is equal to negative 90, and that was the addition property. And then I would divide by this negative 6 on both sides. I'm not going to write it, because typically you don't write what you're doing from step 1 to step 2. You just write the simplified version. So I divide by negative 6 on both sides, and I get exactly what I was trying to prove by using the division property. So if you notice, the last step of a proof is always what you were asked to prove. All right, moving on to the next page, another equation. This one's a long one. So please make sure to draw your vertical and horizontal line and write statements and reasons, and then go ahead and write your given. Okay, so what we're going to do first, or what we logically do first in this type of equation, is we use the distributive property. And I can do both of the distributive properties at once, since I'm using the same exact reason for that step. I'm going to distribute the 4n and the 3n at the same time. Now I'm going to combine like terms, and that's called simplifying. Now, there's different ways that you can go about this. What I'm going to do is I'm going to subtract the 12n over to the 17n, and I get a 5n plus a 28 is equal to a negative 27. You could have subtracted the 28 over using the subtraction property first. So steps 4 and 5 could be out of order. It does not matter. But this is the way that I'm doing it. Now I'm going to use the subtraction property again to subtract this 28 over to the negative 27. So I get a 5n is equal to a negative 55. And then lastly, all I need to prove is n is equal to negative 11. So using division property, I can divide by negative 5, or I can divide by 5 on both sides to get that n is equal to negative 11. Okay, so these are algebraic proofs. Quite simple because we've already learned how to solve equations. So it just flows logically on how we were to solve algebraic equations in the past. But now we're going to get to some geometric proofs. We're going to start with some simple ones. But the first two proofs are actually really important for you to understand. And there's a lot of information that I'm going to be stating that you do need to grasp. All right. So for number 5, we draw your T and draw statements and reasons, but then also state your given. Now it's a good idea to look at what you're given and what you're trying to prove. We are going to use our given to try to get to what we're trying to prove. Now, look at this. We have the measure of angle 1 is equal to 45 degrees and the measure of angle 2 is equal to the measure of angle 1. So what I could do is, since the measure of angle 1 is equal to 45 degrees, I can take this 45 degrees and I can use substitution only because I have these equal signs in both of these. I can use substitution and substitute this 45 degrees in for the measure of angle 1. And then what I would get is the measure of angle 2 equals 45 degrees, which is exactly what I'm trying to prove. So that's one way to do this. Another way to look at this one is, since both the measure of angle 2 and the 45 degrees are equal to the same exact angle, we can then set them equal to each other. And if we look at it from that perspective, that is the transitive property of equality. So we can go straight to what we're trying to prove. This is a two-step proof. And you can either have your reason for the second step being the transitive property of equality or substitution. You do not need to write down both. However, let's look at number 6. This is very important. We see all congruent symbols. So right away, you should know or notice that for number 6, you will not be able to use substitution because we are not dealing with equations, we are dealing with congruent statements. So, drawing your two-column proof, statements and reasons, our first step is given to us. We have angle 1 congruent to angle 2 and angle 1 congruent to angle 3. We're trying to prove that angle 2 is congruent to angle 3. Well, since we know that angle 1 is congruent to angle 2 and angle 1 is also congruent to angle 3, since angle 1 is congruent to both of those angles, we can say that those angles are congruent to each other. Again, this is not substitution because we have congruent symbols. This is the transitive property of congruency. Notice the difference between what I put here and what I put here. Those are different. The reason why we said equality up here is because we were dealing with equal signs. Down here, we're dealing with congruent symbols. Okay. Now, number 7. It's going to be a little bit longer of a proof. In our given, we have an equation, an equal sign, and a congruent symbol. We cannot interchange equal signs and congruent symbols. So I cannot take this 90 and substitute it in for angle A because this one has an equal sign and this one has a congruent symbol. So that's not allowed. So we may need to do something that we learned a couple of videos ago when we changed a congruent symbol into an equal sign using the definition of congruence. So I'm going to take this angle A congruent to angle Z. I'm going to change it into the measure of angle A is equal to the measure of angle Z using the definition of congruence. The reason why I do that is because now I have a consistent symbol between these two, and now I can work with those two things. Now, measure of angle A is equal to 90 degrees, so I can take this 90 degrees and I can substitute it in for the measure of angle A. That's one way of looking at it. And the reason why I could use substitution there is because I have equal signs. Or, since the measure of angle A equals 90 and the measure of angle A equals the measure of angle Z, I can set them equal to each other. If I look at it from that perspective, that's the transitive property of equality. So for the next step, I'm going to say the measure of angle Z is equal to 90 degrees, and that is either transitive property of equality or substitution. It is up to you. You do not need both. But then if I know that the measure of angle Z is 90 degrees, I can say then angle Z is a right angle because that's the definition of a right angle. This is our proof. All right, moving on. We got 2 more proofs to go. This one's already kind of filled in for you. We're just going to fill in the blanks. So I have O is the midpoint of NW, and I also have NO is congruent to OC. You will notice in step 1, I only used part of my given. For experienced proof writers, you can split up your givens. So if you want an extra challenge, you can go ahead and split, if you're given multiple givens, you can split them up so there's more of a flow in your proof. But I'm not expecting you to be able to do that. Like for example, in this one, I was given multiple things and I just put it right in one step. Even though I didn't use this one right away, I used this one right away. That's okay with me. But our first steps are given. Now it says NO and OW are congruent, which is something we're not given, but we were given that O is the midpoint of NW, so logically flowing with that statement, that would mean NO and OW are congruent, which is exactly what we said in step 2. That is the definition of a midpoint. And remember, I abbreviated that. Your next step is something that's given to you, so that's our second given. NO is congruent to OC. Well, if NO is congruent to both OW and OC, that means that I can say OW and OC are congruent to each other. And I cannot use substitution here because I have congruent symbols. That is the transitive property of congruency. All right, we are on our last one, which is something we're going to write together. I'm going to put our given all in one statement. So the very beginning, that's my given. Now, if I know that E is the midpoint of AC and BD, that means I know AE and EC are congruent, and BE and DE are congruent. So I'm going to say that next. I can say that all in one step because it's the same exact reason for that. But then what I'm going to do is I'm going to use these 2 blue statements and say BE is congruent to EC using the transitive property because they're both congruent to ED. And then since AE and BE are both congruent to EC, I can say they're congruent to each other